Now we are going to look at the last mechanism in our syllabus, the mechanism 9, the unimolecular nucleophilic substitution, SM1. And this is also a very important mechanism because a lot of product can be formed from haloalkane. For example, another haloalkane, alcohol, ester, ether, and amine. This is similar to SN2, but the big difference is SN1 favored the tertiary reactant. Step 1. The formation of carbon cation. Initially, the bromine atom in the 2-bromo-2-methylpropane leaves the substrate. The two electrons in the sigma bond between the carbon and the bromine are pushed towards the more electronegative bromine atom. And this process is a slow process because it involves the departure of a leaving group, in this case is the bromine atom, from the substrate molecule. So breaking a covalent bond requires energy, which causes this process to be slow. And as the bromine atom leaves the substrate, tertiary carbon cation is formed, and also a bromide ion. And this formed terpene carbon cation is stabilized by the neighboring methyl group through hyperconjugation, which increases the stability of carbon cation. And this stabilization is why tertiary carbon cations are favored in SN1 reactions. In the second step, the nucleophilic attack a water molecule acts as a nucleophile and attacks the tertiary carbon cation. The lone pair of electrons on the oxygen atom of water forms a bond with the positively charged carbon atom on the carbon cation. The two electrons are pushed towards the positively charged carbon atom. And due to the high nucleophile concentration, the reactivity of carbon cation and the stabilizing effect of water provided to the carbon cation, this process is a fast process. So after this process, we get a protonated water as a pair of electrons is contributed to the positively charged carbon atom just now. So now we come to the last step, the deprotonation. As the protonated water is highly unstable due to the positively charged on the oxygen atom. And this instability causes the oxygen atom to quickly lose a hydrogen atom to the neighboring water molecule. And the two electrons in the sigma bond between the positively charged oxygen atom and the hydrogen atom are pushed toward the more electronegative oxygen atom. So now, as the hydrogen atom leaves and the positively charged is removed, we get a hydroxyl group here. We change the 2-bromo-2-methylpropane to the final product we get is 2-methyl-2-propanol. As the water extracts a hydrogen atom, we get a hydroxyl ion, H3O+, and the bromide ion is from the early state of SN1. And this process of deprotonation is also fast due to the reactivity of protonated water because it is very unstable. So this is how the mechanism of SN1, the unimolecular nucleophilic substitution. A 2-bromo-2-methylpropane is converted to 2-methyl-2-propanol. That's all, thank you.